Um, when we had first level quadratics, and by first level I mean this coefficient was always a 1. It was pretty easy to factor. We had 3 or 4 rules that as long as we went through those 3 or 4 rules, we could always factor it. Well, when you get to second level, notice the very first thing, which is I cannot factor out a greatest common factor. Certainly cannot divide every term by x, and I can't find a number that divides evenly into each of these coefficients either. So I have to factor this in a similar way as I factored the other one. I'm not going to spend a whole lot of time on these, but I did want to point it out to you because just to show you that those rules don't cover all quadratics. Step 1 is still the same. Step 1, you have to split apart that. So how can I split apart that? In other words, whatever I put there times whatever I put there is going to equal 2x squared, not x squared like it normally would be. Well, what
2x.
Okay, I can put 2x and x. Now, that's equal to 2x squared, so far so good. However, you should be aware that the moment that this coefficient is different than this coefficient, it's going to wipe out all rule 3. And I'll show you what I mean. The second step is still the same. What's the second step?
Plus in each.
Okay, determine the signs. They're both the same and they're both positive. So it's plus plus. Now this is where things change. I can no longer say, I still need factors of 12. So I still need one of these sets of factors over here. But I can't make any statements, like I can't say factors of 12 that add to the number 11 or subtract to the number. At this point, it becomes trial and error, okay? And even if you were doing this using what they call the California method or the diamond method, it's still trial and error. So you still have a trial and error process. And the first set of factors that you should always try are the 2 that are closest together. Only because 90% of the problems you will run into over the next 4 years, the answer will be the factors that are closest together. You just have to arrange how you put them on there. But so just randomly, I'm going to try that set right there because 4 and 3 are closer together than 6 and 2. Okay, so I'm going to randomly put the 4 here and the 3 there. Does that result in a correct middle term? And this is where you have to use the double smiley face system. Even though we don't know we have the answer and we're not checking to make sure our answer is correct, we're just checking to see what middle term gets produced. I still know that I'm going to produce a 2x squared here and a plus 12 over here. But what I'm trying to do is find the right combination of factors to produce this plus 11. Well, what does this set produce?
7.
Well, what's 4 times x?
4x.
What's 2x times 3?
And 6x.
Add those together. That's not correct, is it? In other words, we're trying to get to 11x. We only got to 10. Okay, so let's go. You still there? Jenna? like we're having those difficulties again. Are you back? Jenna? Jenna?
Yes.
You're back, okay. Tell me something. When you lose audio, does the screen freeze always also?
No.
Okay. The important part is the screen freezing, because we can do the audio through my phone, just like we were doing it for a month. Okay?
Yes.
So if you have audio problems, be sure and say something. Well, like right now, my thing says you're offline. Can you see? I'm going to write a number. You tell me what number I'm writing.
Okay.
What did I just write?
It won't show it.
I wrote a 7. So your screen is frozen. So that presents real problems. Can you use the computer you were using before you went to your iPad?
Yes.
Okay, let's do it. In other words, let's have you, and then what I will do is call you on my phone. And we'll do the audio that way, but at least we'll have a consistent screen face. Okay? So what I'd like you to do is log off the GoToMeeting right now, go into your other computer, and log on with that same meeting ID number. I won't shut it down and restart it. Just use the same ID number that I texted to you. And then as soon as I see you come back on, I will call you by phone, and we'll do the audio the old way.
Okay.
Okay? Okay. This should work fine for me. Does it work okay for you? Okay. So what we just discovered is that if we put the 4 here and the 3 there, it doesn't produce the proper middle term. So the next step is to switch them. Let's put the 3 there and the 4 there. What middle term does that produce?
3x and then 6x.
Hold it. What's 4 times 2?
8x.
Okay. Don't get multiplication and addition mixed up. So that does produce the correct term. So that is our solution, fully checked. And now let's solve the equation. What does it mean when two things multiplied together are equal 0?
one of them has to be 0?
Yeah, or actually, we're going to let either one of them, in other words, we're going to let both of them be 0 and come up with two solutions. So one solution is going to start with 2x plus 3 equals 0. Solve that equation. Please. What's the first step? Minus 3, okay. So you get 2x equal minus 3. Next step. It's always the last step in solving an algebraic equation. Divide by that coefficient.
Oh, okay.
Okay? So, in other words, this is always the goal, is to get it down to x. So basically, all we're doing is chopping away everything. We started with 2x plus 3. We got to get rid of the 3. And now we got to get rid of the 2. Well, the way you get rid of these things is by always doing the opposite. The 3 was being added, so we're going to subtract it. The 2 was multiplying, so we're going to divide by it. So the answer is x equals minus 3/2. That's one answer. What's another answer? If I go to this part of the product and say, okay, x plus 4 equals 0, solve that.
Minus 4.
So this has two solutions. That's one of them, and that's another. And if I were to go back into the top equation and plug in either of these solutions, I would get 0. In other words, they would work. Okay? All right. Let's not leave this for a second because I want to go up one more level of difficulty. It's relatively easy when it's a plus here. In other words, it's still a trial and error game. But when there's a plus there, we know it has to be plus and plus. Well, if I make that a minus, let's make this a minus 3. Well, first step is still the same. Split apart the 2x squared. Second step is what? What do the signs have to be?
They have to be the same.
No, they have to be opposite.
Opposite.
Opposite is what produces this. Remember, when you multiply a positive number times a negative number, you always get a negative. Or if you multiply negative times positive, you get negative. You only get a positive when you are multiplying a positive times a positive or a negative times a negative. So when I look at the sign that's on this constant, 12, and see that it's negative, it tells me that these have to be different. The problem is now, because this is a 2 and this is a 1, this does not mean the same thing as the reverse. Minus plus. They're going to be different now because one of these numbers is going to be multiplying this and another one's going to be multiplying the 2. So to solve that problem, I put them both up there. There's one plus minus, and there's the allowance for a minus plus if they need to be that way. Okay, well, we go over here, we list our factors. You don't always need to list the factors, but if you don't know all the factors of a certain number, it's nice to list them like this. Okay, again, we're going to start with our two closest ones. But the thing is that there's a lot more trial and error now. Now, let me think for a second. If I do here, hold on. Let me do it this way. I'm going to do it this way. I'm going to start there. And you can start anywhere. For that matter, you can start with any of the factors. I'm just giving you a hint that if you want the solution in the least amount of time, start with the factors that are closest together. Okay? Well, when I try 3 here and 4 there, remember, I can try these in 4 different combinations. I can try the 3 up here and the 4 there, or I can switch the numbers and choose 4 there, 3 there, or 4 up here and 3 there. So there's 4 possible ways to arrange these factors. Remember the goal. The goal is to produce a middle term that is that. We know the minus 12 is correct. We know the 2x squared is correct. So, what's the middle term when I have it set up like this?
Negative 3x on top of that.
Hold on a minute, just a second. I meant to make that a 5. It's hard to come up with these off my head because I got to do the multiplication in my head. Okay, so our goal is to produce minus 5x. Okay. What did you say this produces?
Negative 3x. Then 8x.
Does that add to?
5x.
Plus 5x. Well, when you get the number right, but the sign wrong, that means is all you have to do is move the 3 to the positive and the 4 to the negative. Notice that if I do that, now do the double smiley face, and you get plus 3x minus 8x. Add those together, you get minus 5x. And it always works that way. In other words, if you come across a set of factors that produce the correct number but the wrong sign, just move them down or move them to the other sign. Okay? Now, that is important because let's say I started like this as my first trial. Well, what does that produce in the middle? 4x minus 6x, which is minus 2x. Well, that's not the right number. That's a 2. We're looking for a 5. So there's no point in moving the 4 down to the negative sign and the 3 moving to the positive sign. I don't have to try that trial anymore because I know that that would produce a plus 2x. So I've eliminated one of my necessary trials of, instead of 4 trials, I now at most only have 3. And you can almost always eliminate it to 2 by using this logic. But I think it does begin to show you why, when this is a negative sign, these problems become that much more difficult. Okay?
Yeah.
And if you want top degree of difficulty, do something like this. Why is that so difficult? Because the first step is no longer so easy. This could be 6x times 2x. It could be 4x times 3x. It could be 12x times 1x. Although, again, I'm going to always suggest a first step of using the 2 closest factors. That would automatically be my first step. And then I would go from there. But notice there's also lots of factors of 24. So these can grow in difficulty by leaps and bounds if this coefficient has lots of factors and this coefficient has lots of factors. But you know what? You're never going to see a problem this hard in high school. Just not going to happen. Okay? You may see problems like this, you know, where there's only one set of factors for that, and so forth and so on. But let's go on. We got 10 more minutes. I wanted to hit on one other thing here. What is that equal to?
3x, not x, 3.
Just 3. Square root of 9 is 3. Why? Because 3 times 3 equals 9. Okay? Now, how do we solve that? Well, there's two very important formulas. Let's go over them before I even let you answer. One says this, that if I'm taking the square root of two numbers that are being multiplied together, I can separate that into the square root of the first number times the square root of the second number. Might seem like an obvious step, but it isn't. This is vital for simplifying radicals. And likewise, this is true. A divided by B is going to be the square root of A divided by the square root of B. Okay? You see these two rules? Okay. Well, let's leave that one on the table. And if I take this and want to break it up, I need factors of 18. Well, I also need one of those factors to be a perfect square number. So, yeah, and then I can now say that the square root of 9 is 3. So, square root of 18 simplifies to 3 square root of 2. Okay, so when you have these, Pi, come here, Pi. When you have factors of numbers that are not perfect square numbers, give me a list of perfect square numbers, starting with 4.
4, 8.
No, not 8, 9. In other words, 4 is 2 squared, 9 is 3 squared, what is 4 squared, and so forth?
16.
5 squared?
25.
6 squared?
36.
That's about all you have to remember. You have to know these numbers, because when I am simplifying radicals, I'm always looking for a factor that's one of these numbers here, such as, let's simplify that. What are factors of 32 where one of them is a perfect square?
9 and 4.
No, 9 times 4 is 36.
8. 8 and 4.
8 and 4, okay. We'll do 8 and 4. Well, there's 4. There's 8. This becomes a 2. However, root 8 isn't simplified. A number is only simplified if it can't be broken down further. Notice that root 8 is, again, root 4 times another root 2. You with me?
Yes.
This becomes a 2. 2 times 2 is 4. And there's my answer. 4 root 2. Well, notice I got there in 4 steps. Could have gotten there in 1 step. Why? Because if you happen to notice, 16 is also on that list, and it is a factor of 32. So if I went back here and broke this up into square root of 16 times square root of 2, well, now that immediately becomes 4 root 2. So I got there in 1 step rather than, or 2 steps rather than 4 steps. So you're always going to be at an advantage if you can figure out the maximum, the biggest factor that is a perfect square number. Okay? And the reason I say these are the only 5 you're going to have to memorize is because, in other words, if I say what's the square root of 50, well, you know that doesn't divide into 50, or no number bigger than that divides into 50. So, what is the square root of 50 going to be?
25 and 2.
So what's the final answer? You're right, it's that. When you say 25 and 2, I would rather you say the square root of 25 times the square root of 2. And then what does that simplify to?
5 square root 2.
You got it. Okay. So these are relatively simple. It just requires a bit of imagination and the ability to factor numbers. What's this?
10 square root 10.
Just 10.
Square
10.
root 10.
Correct. No, it's not that. In other words, it's the square root of 10 times the square root of 10, which is 10. But make sure that on what's on one side of the equal sign is always the same number as what's on the other side. So the square root of 100 is 10, so that's a perfect square number. So how would I reduce that?
20.
If I do this, I've factored it. No doubt about it that 10 times 20 is 200. The problem is neither one of these numbers is a perfect square number. Can you factor it into two numbers where one of them is a perfect square number?
102.
There you go. That's what I'm looking for, because now that immediately becomes 10 root 2. Okay? All right, let's take just one or two more quick examples. Square root of 10 is what?
Square root 5 square root 2.
That is a correct statement. Okay? These two are the same. The problem is there's two terms over here. There's only one term over there. Well, one term is simplified more than two terms. Okay? So we don't ever do this. You leave it as square root of 10. You only simplify something if you can pull a perfect square out of it. Well, I can't do it with 10. How about 21? Is that simplified or not?
No.
What would that be equal to?
7 and 3.
Ah, but those are not. You see the problem?
Yeah.
I can't pull a whole number out of that. So that's the best I can do, which means this is the answer. Square root of 21 is the way you leave it. You only reduce it if you can pull a square root out of it. In other words, square root of 8 I can reduce, because that's the square root of 4 times the square root of 2, and that is a perfect square number. So it becomes 2 root 2. So you're never going to see that kind of an answer in math. You'll always see it expressed like that.
Okay.
Okay? All right, that's a good place to stop. We will pick up again next time. I guess I would suggest to you that let's use this computer and this method from the get-go next time.
Okay.
There must be something going on with that iPad that causes it to freeze up. It might just be the app that you got is not quite up to par. All right, Jenna, let's see. I think I need your dad's email address.
Okay. Let me ask him. scott.nelson@experis.com.
Tell me if I'm spelling everything correct here.
scott.nelson@experis.com.
At what?
Experis. EXPERIS.
EXPERIS, experis.com. Okay.
Yes.
That it correct there?
Yes.
Okay, I'll just send my envoys to him.
Okay.
Okay, and I will talk to you on, what is today? Today's Wednesday. I'll talk to you on Friday. Okay.
All right.
Bye-bye.
Thank you.